Okay, so I've got a board from a HVAC unit, consumer HVAC unit. I think it might be a heat pump. I'm not sure. So this belongs to a friend of mine I used to work with. He's since retired, and he says, I think the compressor would not engage, and the HV tech couldn't find anything wrong with the higher low pressure switches, anything like that. So he had a new board put in. He just went out and had the guy order a board, put it in. It works perfect. He's like, can you just take a look at this and see if you see anything awry? And if you do, just go ahead and fix it. I'll have a backup that way next time it goes out. So the main thing about this video is I want to go ahead and apply the 24 volts AC between the R terminal and the C. And it's the same. So I've got the printout from the inside of the HVAC unit, and I've determined that the 24 volts AC comes in on P6 pin 1 and 3. So I just want to go ahead and we'll zoom out just a wee bit. I just want to get a meter. It's in the continuity scale. So if it finds continuity, it beeps. And I do know that this is P6 pin 1. And I do have 0 ohms to the C terminal. And open on the R. This is pin 3. And it says, okay, 2 ohms, 0. That's fine. So I'm just going to go ahead and hook up this transformer from a stereo. It's from a Onkyo TX NR727. And what I've done on this, you may have seen this in a previous video on a Denon, I think it was, where I needed to power up one of the 7 amplifier boards on the bench. So I just added a bridge rectifier, and then I do have a couple of discharge resistors. I think they're 10K or well, those are 30K resistors. And it's not much, but it's a 220 microfarad 100 volt caps to supply the positive and negative output on these super thin little leads that I attach directly to the circuit board. I'll actually try to put a link to the troubleshooting up here in this corner right there, if I can figure out how to do it, and if I have time. Once again, hectic times. Okay, so I do have a couple of alligator leads that I'm just going to go ahead and attach. We'll put them down here, and I used red and red. I don't think they're going to short to anything. There we go. That should be fine. So we're going to get the Fluke. This is the 115 out, and get rid of the reflections on the screen. I'll just put it in AC volts, and I'm hooking up the leads there. And so if I do an ohm check on it now, we should get just a few ohms of the secondary. Yeah, 1.1. Okay, I do have a cord attached to it, which is a standard plug-in. I'm going to put it in my Variac, and we'll power it on there, and we'll bring it up to 24 volts AC output. That's close enough, 24 and a half. And so I'm going to use that 24 volts AC to feed into this board right there. I am currently at 30 volts. So I'll power that down, move that out of the way. I wonder if I should add some leads. Yeah, I probably will, because I'm going to want to flip this over. These are the 2 driver transistors right there for the relays, and then there's the reverse EMF protection diode right there. These 4 diodes are the bridge rectifier. I guess I could actually zoom in on it. So yeah, those 4 diodes are the bridge rectifier diodes, and they actually drive the relays directly. I've done a little bit of reverse engineering. They drive the relays directly, and then it passes through that one diode right there, D7, and is filtered by this capacitor C2. So what I'm wondering, I think both of these transistors are driven off of this little microprocessor. Just says 030, custom design little micro that really doesn't do much. I think those are MPS A05s. So, and I've done a little bit of research, and I know that K1, the relay K1, is driven by K2 or Q2, and then R20 is the resistor that resides between the base of Q2 and the output of the microprocessor. And then on K2, it's driven by Q1. How appropriate they reverse these. Well, way to go, engineers. And it is driven, Q1 is driven by R19, which is another 10K resistor to one of the pins of the microprocessor. So I'm thinking the first thing I need to do is figure out, I believe the AC, AC comes in right here and right here, and then these are the outputs of the diodes. And we can make a really easy determination as to which one is the positive and which one is the negative based on the direction of the diode that's in here. So I can see that this first lead right there and this third lead is on this common trace, and it does go to both sides of the coils. One side of the coil on both relays, and then this side of the coil goes through the reverse EMF protection diode right there, and it goes to one lead of the transistor, probably the collector, and then this is going to be the emitter that goes to ground. There's the base, and it goes through this resistor, and if you follow that line, it goes through, it goes right to the microprocessor pin right there. So that pin right there, so we know it's 1, 2, 3, 4. Pin 5 is the drive output to one of the relays. And then if we follow the other relay or the other drive transistor, it goes through this resistor, a 10K, and it goes to pin 3. So pin 3 and pin 5 are the drive outputs. Now here's the filter capacitor right here. Remember, I believe this is the positive lead right there. It goes through this diode, which is like a decoupling diode, so that if this voltage on this side were to pull down because of the inrush of the capacitors, this diode will not reverse connect, and this capacitor will stay charged and keep this little microprocessor active. So I believe this is going to be the positive lead. Once again, we can determine that by looking at where the cathode is on the first diode and the third diode. If the cathode is on this side, then this is definitely the positive lead. If the cathode is on this side, then this is the negative lead. So we'll turn that over, and I certainly can see that the cathode is on this side and this side. So we know for sure that this lead right there is going to be the positive lead, and then right there, so yeah, these are going to be the emitters most likely, and they're going to be driving these bases high to pull in these relays. So what I need to do is attach a lead onto here somewhere that I can attach a negative lead to my meter so I can measure voltages accurately. So I think it's probably too close to attach right there, but I think I can probably just go ahead and solder it on the bottom of the board and just let it stand up. I don't see that it really goes to any of the terminals, which is less than helpful for me, but we'll make it work. Let me solder this on, and I shall be right back. One moment, please. Okay, so I do have a ground terminal attached. That's going to be the DC supply ground. And so I'll get one more test lead over here. I'll get a black one. There we go. And then I did disconnect these to do the soldering. So we have one on the C lead and one on the R. This is AC power going into this unit. So there I have a connection to my voltmeter right here. And we'll zoom out just a wee bit. Okay, got my transformer set up over here. We'll put this on volts. And I'm just going to go ahead and throw the switch on the Variac, power this board up. Let's get something under there so you can see the meter. Okay, that looks better. Actually, I can zoom in a little bit now. Okay, that should be good. I'm sorry if that's in the way. Okay, power on. Looking at the current, very, very low current, just the quiescent current of the transformer, most likely. So I am in DC volts on auto range. So first I just want to look at this lead and see what we have. We have 22 volts DC, but this is unfiltered, so there's going to be a major AC component, 8 volts of AC on it. And then over here on this main filter cap, we have 30.8 volts, which should be basically 22 volts times 1.414 if it's unloaded. And then do we have any AC? Wow, we have 0.35 volts of AC. 350 millivolts. That's quite a bit for being completely unloaded. Just to make sure, we'll go back into the AC and I will measure, well, let's do it over here, between pins 1 and 3, and I should have 24, and I do. Perfect. So over here on this board, let's just go ahead and fold these guys back a little bit. And then I just want to look at the, put it on 60 volts so it doesn't auto range. The collector 22, the collector 22, perfect. And now I think this microprocessor should be getting a run voltage, and probably from this Zener diode, which is 10.5 volts. So I'm just going to go ahead and try to turn these things on if I can. So to do that, I'm going to grab, only because it has a built-in 3K resistor, I'm going to grab my 117 right here, and I'm going to put it in the low impedance mode, the low Z mode. I don't really care what it says on the display. Doesn't matter. Once again, thank you, Dickie, for donating this meter to me. I really do appreciate it. I just want to go from the 24 volt supply. So this is going to be across this relay. So the cathode should be hot. And why do I have nothing? Well, that's interesting. So it's only got 15 volts loaded. That's with a 3K load. Wow. Still got 30 volts on that side, so that's good. So this should be the microprocessor supply. It's got 16 volts of AC. Maybe this is it. Oh, it's got that stupid coding. Huh, okay, that one. Okay, there's 5 volts. Sorry if that was off the screen. I'm actually measuring the voltage on this meter that we said we wouldn't look at. And so I've got 5 volt. That's probably the supply for the microprocessor. And so the whole point of using this meter was to be able to, in the low impedance mode, I'm just going to go ahead and take that supply off of that diode right there and drive the base. Okay, that's good. Oh, my bad. The reason I wasn't getting anything, this relay is not energized. So I should have voltage from the positive side to ground over here, but I should not have anything on the negative side. And just by this little test, both relays are good. That doesn't mean the microprocessor is working. It still may have problems. let's go ahead and kill the power to this unit and just ESR that cap. Come on, there it is. It's stuck. Okay, meter is zeroed, power is off. And I only get 1.2 ohms on it. And it's a 47 microfarad at 63 volts. So one more test that I want to do is make sure the relay contacts are good. Maybe the relay's pulling in, but the contacts have burned up. Maybe that's the whole problem. So I want to go ahead and attach terminals where the relays are. So there's K2 and then there is K1. So I just got to find out where this goes through what? Low pressure, high pressure? What is that? Part of the micro maybe? I don't know. Okay, sorry, that was off screen. Okay, so there's K1, and somebody has this circled on the schematic, and it pulls in the contactor M1. I have the rest of the schematic on my laptop, but I'm wondering what is that? It shows a low pressure input, and there's the low pressure cutout and the high pressure cutout. And what that does is if the condenser fan motor's bad or the condenser is plugged up with dirt, dust, and it can't cool adequately, once the high pressure switch is opened, it opens the contactor for the compressor. And then if you have a leak in your system and the refrigerant level gets low, too low to pull in the low pressure switch, once again, does not allow the compressor to run to protect the rest of the system. So there's K1, there is K2. I can easily get to the leads for K2 because they go all over the board here where the AC comes in. And it comes out on XL, I believe that is. K1 for some reason shows that it's in between the high pressure input and the compressor output. So that might be the main compressor contactor. So yeah, let me get some test leads hooked up, and I'm gonna get a light bulb. We'll actually drive a car headlight bulb, which draws about 4 or 5 amps. So that'll definitely test the contact integrity. 5 amps is what they're both rated at 250 volts. Okay, one moment while I get this thing hooked up. We'll test the relay contacts. Okay, here we go. I've got the leads connected between the XL connector and HP, which is K2 relay, I believe. And so I'm using just another test lead right here. By the way, these are the Harbor Freight test leads. I don't think I need the ground connected, but I will reconnect it because it did pop off. Okay, ground is connected to the meter. So first thing, I just want to short across the XL to HP and make sure the light does light up. You can see the light off screen. Next, in the low impedance mode of the Fluke 117 that is sitting right here, we'll go ahead and do the same test and drive the base. Oh, help if I turn this back on. Okay, power is applied, it was off. And the contact in that relay appears to be perfectly fine because you can see the light turning on and off. Okay, next for K1, that was K2. Okay, leads are reattached, and at this point I'm going between M1 and LP right here, and we'll just get another test lead. In case I didn't say it, these are the Harbor Freight modified test leads, and then the lamp works perfect there. You can see it. I mean, it's not in the shop, but you can see it lighting up the bench and my hand. Next, with the Fluke 117 in the low impedance mode, I'm just using this as a resistor. Basically, it's a 3K resistor, nothing else. We'll turn this transistor on, and the light does light up. Okay, so I've established that basically the drive circuit is good, The relays are both good, and the rectification here is sufficient to pull in the contacts on both relays. So now I'm going to have to dive just a little bit deeper and try to fool this into thinking that it is actually connected in the unit. We'll have to add some jumpers to fool the high pressure, low pressure switches. And then I think it's Y1 and common. We'll have to short that to tell the board that the thermostat is calling. And I think there's a fan input. I'm not familiar with what that one is. And then we'll have to tell it it's going to be in the cool mode with the switch on the thermostat as well, I do believe. Could be wrong. Not an HVAC guy, but I do have a basic knowledge of HVAC systems. So anyhow, that's going to wrap up this part. I'm sorry I haven't produced more videos lately. Things have still been semi-hectic. It's definitely getting better. And then the wife and I weren't feeling well, and then we took a trip to the coast for a couple days, watched the ocean, and I'm trying to get caught up. Just been hectic. So if I have your unit and I haven't responded, I'm so sorry. I am getting to them slowly but surely. It just takes more time than I currently have based on personal issues. All right, everybody, thank you for watching. This was meant to be a very short video, but I think it's going to be probably 20 minutes or so with not much editing whatsoever. You can follow me on social media, Facebook, Instagram, Twitter at NorCal715. You can email me, NorCal715videos@gmail.com. That is the best way to contact me. Once again, if you have tried on Facebook, Instagram, or Twitter, I rarely check those if ever. And honestly, on the Gmail at this point, being the first part of May of 2023, I've only checked maybe 5 emails in the past month since the accident. It's been so hectic. So once again, I want to apologize. Thank you, everybody, for your continued support, especially those who have donated to my daughter's GoFundMe, or even made like a super thanks for me helping repair your unit. I very much appreciate it. Everyone, thank you for making it to the end of this video. I really, really appreciate it. Thanks for watching. Have a great day. Bye-bye.